Hello, everyone. Good morning, good afternoon, and good evening from wherever you're joining us today. My name is Dalia. I work as a community manager here at Kong. I'm very happy to welcome you all to our webinar today. We have Michael Heap, who will talk to us about the Kong Ingress Controller, and more specifically, the 3.0 that was just released. Very exciting stuff to share with you all today. Very, very exciting presentation and some demos. We'll take all of the questions at the end. So you can see on the bottom, there is a Q&A function. So please use it to insert all of your questions there. And we'll go over them as soon as he's done presenting. So with that, Michael, please take it away.
Thank you, Dalia. As Dalia said, good morning, afternoon, or evening, wherever you are joining us from. We do have a diverse group here today, all over the world. Oh, 1, 2, 4. I'm Michael. I'm a Senior Director of Product at Kong, where I look after all of our Kubernetes-related products. Don't leave the call just yet, though. Because although I am Product Manager, I'm not just going to talk about features and business value, because this is a tech talk, after all. I can promise you that you'll get to see no fewer than 6 live demos on this call, and if I'm really lucky, all 6 of them will work, as I expect. But before I dive in, I did want to take a moment to talk about Kong Ingress Controller 3.0, which is what I'm going to be showcasing today. I'm personally excited for this latest major release of Kick, which is due in no small part to the availability of version 1.0 of the Kubernetes Gateway API. A lot of you will be familiar with the Ingress resource. It's been around for a long time, about 8 years or so. But it had, I'm just going to call them limitations. But the Gateway API, which hit version 1.0 for KubeCon North America just a few weeks ago, it's the next generation of networking for Kubernetes, and it enables a lot of use cases that weren't previously possible. I'm going to show you 5 of them today. Now, Kick 3.0 is a major version, which means that there are some breaking changes. I'm just going to take a quick look at them before diving into the demos. The biggest one is that Kick 3.0 only supports Kong Gateway 3.4.1 or later. We needed this to be compliant with the Gateway API, as Kong Gateway itself required some enhancements. That's right. Open standards in the Kubernetes ecosystem are driving development of Kong Gateway's capabilities itself. Now, Kong Gateway 3.4 is an LTS release, so you're safe to upgrade knowing that you're going to get support for that extended period of time, while still getting all those latest capabilities. Item number 2 is Knative. We had an experimental Knative integration in Kick for a long time, but as far as we could tell, usage was very, very low. So rather than continuing to carry that complexity, we decided to remove support in Kick 3.0. If you are a Knative user, there's a project linked on this slide that converts Knative resources to Gateway API resources, which can then be processed by the Kong Ingress Controller. So there is still a way to use Knative with Kick. It's just not built in anymore. The expressions router, and this one is only technically breaking. In reality, you won't see any difference apart from getting a nice speed boost. Because in Kick 3.0, we've switched the default router in kickbacked gateway deployments to use the expressions router. Now, the expressions router was introduced in Kong Gateway 3.0, and it's a Rust-based routing engine that is both faster and more powerful than our traditional router. You don't need to do anything here. You just need to continue to write Gateway API or Ingress resources, and we'll take care of the rest. The only thing to be aware of is if you have a large number of very similar or identical routes, route priorities may change. Most people won't hit that edge case though. That's why it's only technically breaking. Most people won't notice any change. Then finally, Kong Ingress. The Ingress resource and to some extent the Gateway API resources, they don't cover all of Kong Gateway's capabilities. Kick 2.x used the Kong Ingress resource to customize service, route, and upstream behavior. But service and route behavior was moved to annotations a while ago, and they're no longer supported in Kong Ingress. So if you're upgrading to Kick 3.0, make sure that anything you have defined in the Kong Ingress for service and route is moved to annotations. And in addition, we've deprecated the upstream portion of Kong Ingress. It will still work in Kick 3.0, but we recommend that you use the new Kong upstream policy resource instead. Now, I said we're going to do some demos. I've got 6. I'm assuming this is what you're actually here to see. So if I dive across to my terminal, I'm going to show you 6 examples today. And the first one's just nice and basic. I used to start with, it's the Gateway API for those of you that aren't familiar with it. Now, the Gateway API is shipped as an extension. So it's not built in to Kubernetes. In order to keep the rapid pace of development, the Gateway API project decided to ship CRDs as a separate thing to the base Kubernetes install. So before I do each of these demos, I'm going to set up my environment. I'm going to install the standard CRDs and the experimental ones, because I'll be using things like gRPC in a little while. I'm going to install the Kong Ingress controller. And then I'm going to enable the non-GA functionality by setting the Gateway Alpha feature gates to true. So if I execute that, we can see the CRDs are being installed, Kick has been installed, and we've updated the deployment with that environment variable. The next thing to do is create a Gateway class and a Gateway instance. Now, these are Gateway API resources. And here we're saying that anything in the Kong Gateway class is managed by the Kong Ingress controller. And then we create a gateway that references that gateway class, and it just listens on port 80. So it's just going to listen for HTTP requests. In future demos, this will automatically get created by that setup script as well, but I wanted to show you it in the first demo just to make sure that you're seeing everything that I'm doing. There's nothing pre-set up. We're doing everything step by step. So now I have a cluster that's running Kong Gateway and Kick. I have a Kong Gateway and a Kong Gateway class, which is about 13 seconds old, and I can start configuring resources. The first one is just an echo service. So it runs a little app that we wrote called Go Echo. And it just reflects the pod name namespace and things in the output. And I can show you what that looks like by adding a HTTP route. Now, one thing about the Gateway API is that it splits the ownership of the gateway itself and all of the routing rules. So your ops team can own the definition of gateway class and gateways, and your developers can write HTTP routes without necessarily knowing how they're being served. There are lots of different route types, HTTP route, TCP route, UDP route, gRPC route, operating at all different levels of the stack, whether it's L4 or L7. This wasn't true with Ingress. Ingress just assumed it was L7, it was HTTP. And vendors had to add additional annotations or custom resources to add support for other protocols. Here, you can see I'm using a HTTP route. It's attached to the gateway named Kong. And I have one matching rule. So anything beginning with /echo gets sent to the echo service on port 1027. So if I curl kubernetes.org.local echo, we can see that the echo service is returned. And that's just through that one HTTP route that we created. And that's the end of demo number 1. So that was just a basic example saying this is how you set up the cluster, this is how you create a gateway, and this is how you create a HTTP route. And it's a little bit cut off, but you can see it just said Kubernetes cluster reset. And you can see I now have no resources in my cluster. So we're going to start from scratch again for demo number 2. This GW API is a little alias I have. You can see it's installing the CODs, it's creating the Kong release, it's doing everything that I showed you in that setup script. And I'm going to move on to demo number 2, which is traffic weighting, because this is something that the Gateway API specifically adds. You can't do this with Ingress. So just like before, I'm going to create some services, but this time I'm creating 2 services, Echo and Echo 2. And here, this is I create a HTTP route, but this time I have 2 backend refs. And the way that the Gateway API works is it will distribute them equally across both of those refs. So if I create that route, and I've got a nice little code request here that makes 200 requests and then tabulates them. And we can see that 100 requests went to Echo and 100 went to Echo 2, because by default, they both have the same weight. What I can do is edit that HTTP route. And you can see that although I didn't specify them, they've both implicitly been given a weight of 1. But let's say that for every 1 request that goes to Echo 2, I want 2 requests to go to Echo. So 2/3 of the traffic to Echo and 1/3 to Echo 2. If I save that and run my code request again, we can see that the traffic distribution has changed. This is super useful when you're doing things like canary deploys. If you've got a new version of a service that you just want to send 1%, 10% of traffic to until you're happy that it's performing as it should, and then you can cut over all of your traffic. So that's traffic weighting. Oh, it's not in there. Wait. So traffic weighting, just add a weight to your backend refs, and the Gateway API and Kong will take care of the rest. Which means it's time to reset the cluster once again, and then install all the CIDs and deploy Kong. Because this time we're going to take a look at something that the Ingress resource can't support again, which is gRPC connections. So the thing about gRPC is it works best when run over HTTPS connections. So I'm going to show you how to configure a HTTPS listener in the Gateway API. To do so, we need a certificate. So I'm just going to generate a self-signed certificate for the hostname example.com. I'm going to create a secret in Kubernetes called example.com. And then finally, I'm going to patch the gateway that we have. So if I do kget gateway, we can see that it only listens on port 80. So now I'm going to tell it to listen on port 443, which is the TLS port for HTTPS requests. So let me grab my patch. Here you can see protocol HTTPS port 443, and it's listening for requests to example.com, and it's going to pull the certificate from a secret. So what's happening now is the change in the deployment, the change in the gateway has been picked up, and Ingress Controller will now support any routes that target port 443, which includes our gRPC route. So here we're saying, I want any requests for example.com that are gRPC requests to be sent to gRPC bin on port 9001. So I'm just going to deploy gRPC bin. And to test this, I'm going to use a program called gRPC curl. So I'm going to send it a payload, greeting of Kong. I'm going to indicate that this is for example.com. I'm going to send it to port 443, and I'm going to say it's insecure because we're using a self-signed certificate. And this is where all of the demos didn't necessarily want to work. So it doesn't support the reflection API. So I'm just going to double check that the gRPC controller is actually running. Yes, it is. So this is running because I have the gateway alpha environment variable set. This is a BAT alpha endpoint. Oh, I didn't create the gRPC route. That is why it couldn't support the reflection endpoint, because Con Gateway didn't know how to route the incoming requests. So now if I try again, there we are. It says hello Kong. Change that to hello world. And just like that, Con Gateway is processing gRPC requests using an open standard gRPC route that is part of the Gateway API experimental CRDs. You got to see me debug in real time as well. So that was kubectl logs for the Ingress controller itself. All right, we're getting there. We're 3 demos down, and they all worked. So let's install the Gateway API again, and this time we're going to take a look at cross namespace traffic. This is something that when I was initially learning, I just called reference grant. Something that when I was initially learning, I really didn't understand, because you had to do something like this. So if you had an echo service in a namespace called other, and you wanted to access it from the default namespace, you couldn't. You actually had to create an external name service that pointed to the other namespace. This just didn't make any sense to me. I understand that you want your services to be isolated across namespaces, but having to create an additional service and external name just felt like the wrong solution to me. Fortunately, with the Gateway API, you can now specify a namespace. So here, I'm saying I want to target the echo service in a namespace different to the one that my HTTP route exists in. And by default, this won't work because of the permissions model, but I'm going to show you how reference grant can be used to enable cross namespace traffic. So I'm going to deploy my echo service, and that's in the other namespace. There's nothing running in default. And I'm going to deploy my HTTP route. So just to remind you, that HTTP route is targeting the echo service in the other namespace. So let's try and call echo, and I get a HTTP 500, no existing backend ref provided. So I'm going to get my HTTP route, and I'm going to look at the status. And so a lot of things in the Gateway API uses status conditions to communicate what's happening. And we can see that the ref isn't permitted. And that's because it's referencing a service in a different namespace, and we haven't explicitly told the cluster that it's allowed to do that. The Gateway API adds something called a reference grant. And what a reference grant does is it says, I want to accept any HTTP route from the default namespace. I want to provide access specifically to the echo service. And you can accept requests from a namespace to any service in your namespace. You can accept requests to a specific service or to all services. But what's important to note is that the reference grant lives in the namespace that's running the service. So you can't create a reference grant in the default namespace saying, hey, let me look into other. You've got to have permission to create reference grants in the other namespace in order to let other people in. It's a bit like when you live in your own house. You've got to open it from the inside. You can't just let other people come in from the outside whenever they want. So if I apply that reference grant, and I'll try and make a code request, we can see that the request goes through fine. We get HTTP 200, and we get a response from our echo server, even though the HTTP route lives in the default namespace and the service lives in a different namespace. 4 demos down. Like, this is all Gateway API only. Like, these are things that you cannot do with Ingress. So, next demo, plugins. A lot of you will be familiar with Kong Gateway plugins. And this is something you all know. You create a Kong plugin. Here I've got one that creates a rate limit, say 5 requests per minute. And I'm going to create my echo service. Oh, that's because I forgot to run Gateway API, which installs the Gateway API CRDs and deploys Kong and all the CRDs that I needed, which means now I should be able to create my Kong plugin resource. There we are. At this point, I can annotate my service with that rate limiting plugin. So the conkhq.com/plugins annotation that you're all familiar with. And if I just call it 1, oh, I need to create a HTTP route as well. And I call it 1, 2, 3, 4, 5. And now I'm getting API rate limit exceeded. These is all things that you're familiar with. Nothing to do with Gateway API here. What I'm going to do is delete that HTTP route. And it's not the HTTP route, it's the service. And delete the plugins annotation so that it is no longer protected. And instead, I'm going to show you a new Gateway API feature called filters. So there are some built-in filters for things like header modification, but it's also extensible through this extension ref type. So vendors can extend the Gateway API using their own resources. So here I'm saying that I want to apply a Kong plugin, the name rate limit, which is the one that we created. And the group is just what the Gateway API uses to figure out how to apply this extension ref because they are vendor specific. So if I apply that and go back and make some more curl requests, after 5 requests, I get the API rate limit exceeded. So this is the same functionality that you're used to from Kong, like you create a Kong plugin, but instead of using an annotation, which is vendor specific, you can attach filters to your HTTP route or any other kind of route as part of the Gateway API spec. So let's clear out the cluster one more time and install all the Gateway API resources and Kong. And I'm going to do my final demo, which is the one non-Gateway API demo that we have for today. Because although the Gateway API is a huge step up from Ingress, it's still not exhaustive. So I'm going to show you how to achieve sticky sessions using the Kong upstream policy so that when a request comes in, it gets sent to the same upstream. So if I change to this directory and once again create my echo service and my HTTP route, and if I just do grep pod, there we are. We can see that all the requests go to the same pod because I only have one. But if I scale that up to 3 pods, the default behavior for a Kong gateway is to round robin through the available upstreams. So you can see each time I hit, it goes to one pod, then the next, then the next, then the next. And in fact, if I do all 3 at once, you can see that it round robins. 1, 2, 3, 1, 2, 3. I don't want this behavior. What I want to do is configure Kong Gateway with a consistent hashing algorithm so that a request constantly makes it to the same backend. I'm going to use the XLB header to hash it on. This is just a demo, but you could specify like a business unit or a username or something like that in a header and have that decide which upstream you get sent to. And for requests that are missing that header, it's just going to fall back to using the IP address. So if I create that Kong upstream policy and then attach it to my service using an annotation, let's do this. There we are. Because I'm specifying that XLB header, it's always going to the same upstream. And if I change the value of that and change it again, oh, it's deciding to send it to the same one. Let's change it to something completely different. There we are. It just so happened that all the demos, all the XLB values that I chose hashed to the same target upstream. But there you are. WAA goes to KNSZ4 and AAA goes to KKJJ9. Just one final thing. If I do this, remove the XLB header, just show you that it falls back to the IP address. All of those requests get sent to the same upstream because of our configuration on the Kong upstream policy that says we want consistent hashing based on the XLB header with the fallback to the client IP if the header isn't set. That was a lot. Like, I just showed you 5 brand new things that you can only do with the Gateway API and a brand new Kong upstream policy COD that allows you to customize how the load balancer works in Kong itself. All of them worked. I only made one mistake. I'm happy with that. The demo gods were obviously on my side today. Everything I showed you today is available to you in Kik 3.0. It is just a Helm install away. Helm install your release name Kong/Ingress. And you can start using Gateway API resources today. So why not go and give it a go? And with that, I think it's time for any questions you may have.
Thank you, Michael. Amazing. Let's see. I think we have one question in the Q&A.
We do indeed. How to deal with custom plugins. So exactly the same way you would with the Ingress resource. So Kong Ingress Controller supports custom plugins in a config map or a secret, and it will make sure that ends up in the data plane pod. So if you're using the Helm chart, you can just specify the config map name for your Lua plugin, and we'll take care of the rest. And then with the Gateway API, you reference it the same way you will reference built-in plugins. So you can either use annotations or extension ref. As long as your custom plugin exists on the data plane, everything will just work.
All right, let's see if any other last questions will come through. Any last questions for Michael? Anything on what he covered?
I covered a lot in a very short amount of time, so might be a bit shell-shocked.
So the recording will be available for all of you to catch up on. I will send you the link to our YouTube channel here in the chat, where you will find it in like an hour or so you can rewatch it. Oh, there's one more. Wait.
Man's that. So the Kubernetes Gateway implementation with Kong, I guess the question is, does it support Knative? It doesn't natively. We dropped that supporting Kong Ingress Controller 3.0. But there is a project that will take Knative resources and convert them to Gateway API resources, which Kong Gateway can then pick up and reconcile and handle as expected. And so if you're a Knative user, there is an option. It's just not built into Kong Ingress Controller as of Kik 3.0. Any final questions?
If you think of any last questions, or in general, you can also find us on our Kong community Slack. I will type here the link where you can join and ask questions there.
Yeah, please do. I sit in that community Slack as well, and I'd love to hear any questions you may have, especially if it's gaps in documentation. Actually, that's one thing I should add. All of the demos I showed today were pulled from our documentation. So if you want to go and try it out yourself, every step you need is covered there. You can just copy and paste your way from the top to the bottom and see it working on your own machine.
Awesome. All right, well, I don't think we have anything else coming through. Cool. Thank you so much, Michael, for the great presentation. Thank you, everyone, for joining us today. We hope to see you at our next Tech Talk. Actually, I can put it right now in the chat for you to join. It's about the Gateway API. It will be on December 7th. Here is the link. Here you go. So all of you can join. Cool. Thank you so much. Have a good evening, a good day, wherever you're from, and we'll see you next time. Bye, everyone.